Доброго вечора, українські радіаційні онкологи, медичні фізики. Слава Україні! Дуже дякуємо, що приєдналися до Research Methodology Course for Ukraine. Before we introduce our speaker today, I have an announcement. This is a reminder that the Easter abstract deadline is today, November 12th, and it's actually midnight in Europe. Help Ukraine Group will be organizing a Ukrainian delegation, approximately 15 people, to Stockholm, Sweden, to attend Easter Congress on May 15 to 19 next year. So please let us know if you submit an abstract to Easter or if your submitted abstract is selected. We'll be prioritizing delegates based on accepted abstracts. We are applying for grants to sponsor the trip expenses for the delegation. But if you don't have the material to submit for Easter, don't worry. There's also an opportunity to submit an abstract to Astro Conference in Boston in September 26th, 30th next year. So the deadline for Astro abstract submission is in February 24th. So we are also excited to have 5 presentations on the research projects from this course at the OncoHub Up-to-Date conference in November. So we all hope to see you there. It would be exciting to hear all the amazing talks from your research projects. So let's go back to our lecture today. Our topic is data management and study database setup. And our speaker is Katherine Lajkosz. Katherine is a senior biostatistician at the University of Health Network in Toronto, Canada, supporting clinical research study design and analysis. She's passionate about equipping researchers with the statistical foundations needed to strengthen the quality and impact of their work. Thank you so much, Katherine, for joining us today, preparing the lecture for Ukrainian radiation oncologists, medical physicists. We're really eager to hear and learn from you today on data management and study database setup. I will stop sharing. The podium is yours.
Great. Thank you so much. Let me just quickly share my screen. Perfect. So thank you again for the invitation to speak today. So like you said, I'll be talking about data management and study database setup. So let's just hop right into it. So just a quick overview of the objectives for today. So the first two is to understand the key principles of designing effective data collection forms, or CRFs. The next is to identify important considerations when developing a clinical study database. The third is I'm going to provide a very quick introduction to the REDCap platform and its core features, because I understand that that is a platform that is widely available in Ukraine. And finally, I want to provide some practical strategies for building databases using Microsoft Excel. So today will be a lot about, kind of practicality. So why does database setup matter? So the database setup directly impacts the quality, viability, and reproducibility of research data. Good data equals good research. Poorly structured databases can lead to inconsistent data and frequent database modifications. So, having to go back and double check things because, the database wasn't set up properly. And this can affect study timelines and and this will also increase costs because you have to spend more time going back fixing your data. A well-designed setup enforces data standards, supports validation, and protects against human error. Now, I'm going to give, again, I'm a statistician, so I'm going to give some insight for why it matters from a statistician's perspective. So one thing we like to say is garbage in, garbage out. So not even the most advanced analysis can fix poorly structured or inconsistent data. If the data isn't good, we can't magically fix it. The data itself has to be good quality. Also, if you have transparent documentation in data dictionaries, which I'll talk about later, this means that the statistician doesn't need to, guess what each variables means. So it minimizes the back and forth. Oh, what's this? What's this? What's this? If you design things properly up front, this will be very, it'll be very clear. And additionally, they minimize the errors. They minimize data entry errors and therefore the need for the clinical team to have to go back and review charts. So say a value is blank Was it blank because it just wasn't written down, or was it blank because it wasn't measured? Saves time from having to go back and actually double check. Well-designed databases minimizes time spent cleaning and merging the data during the analysis, and therefore reducing costs. And like I've already alluded to, reduces the back and forth between statisticians, coordinators, data managers, investigators, and so on. So for setting up a database, I'm going to follow the paper, or this paper by Brambilla and colleagues, published in 2018. And so roughly speaking, again, it'll differ for each project, but the setting up a database comprises of 5 steps: data collection, design of the CRF, then database conception, and then building the database, and finally, data validations. So let's go through each step. So the first step is data collection. So basically, what data should be collected? So having a well-defined research question from the get-go will guide the data collection and case report form design process. So if we have a clearly designed research question, we can kind of easily think about, okay, what data do we need to collect? So we need to ensure that our collected data can adequately define, all aspects of your study. So first is the outcome. So, like the primary and secondary outcomes. So if you're looking at survival, you need to make sure you're collecting, date of death. Eligibility criteria. So if your patients must be within have specific criteria in order to be eligible for the study, make sure you're collecting that information. Any relevant groups of patients. So if you're treating patients with A or B, make sure you collect that information. It sounds very straightforward, but it is, sometimes these things can be forgotten at the beginning stage. And then also the rest are kind of specific to like the statistical analysis. So known or potential confounding factors. So what will you need to incorporate into your, analyses? Any known or potential effect modifiers. And also just general characteristics of the study sample that you'll want to use to describe your set of patients. So think about what these, so here I've listed 2 different research questions. So, you can quickly think about what data should be collected in order to adequately answer them. So the first is the impact of radiation therapy on cognitive changes in children with brain tumors. So, okay, so if we want to look at the impact of radiation therapy, we'll need detailed information about, the doses and whatnot that that these patients have received. Cognitive changes. So we need to ensure that we're collecting cognitive data at baseline or, post radiation therapy, or, perhaps you want to collect it at multiple time points. So having a clearly defined research question will allow you to think, okay, we want to look at it at time, 0, 1, 2, 3, 4, whatever that may mean. So if you have the research question defined in advance, then you can clearly, it makes deciding what data to collect really easy. And then of course, so in children with brain tumors, so these are certain eligibility criteria. So we need to collect their age, make sure they're in the right age group. And then also whatever like diagnosis information that may be relevant. So the next question is survival outcomes in patients with anal canal cancer treated with 2 different radiation modalities. So we have just IMRT and 3D CRT. So we have survival outcomes. So we need to look at, say, we need to make sure we collect date of death or date of progression if that's relevant. Also the anal canal cancer. So we need the specific diagnosis information. And then specific treatment data related to each treatment modality. So again, depends on the research question. Sorry, it's lagging. There we go. So step 2 is designing the CRF. So the CRF is also known as the case report form. These basically translate your study protocol or your research question into structured data capture. And I'll give some of the examples of CRFs in the next few slides. But CRFs can be paper-based, so a form you actually go fill in by hand, or electronic. And this depends on the study needs. So a well-designed CRF will have the following characteristics. So all required variables are captured once, clearly and consistently. The questions follow a logical clinical flow, and there's a minimal reliance on free text fields. So what do CRFs look like? So here's an illustration of a demographic CRF. So at the top we have, specific subject information. And then one thing I want to highlight is the date. So I know in Canada we are horribly inconsistent with our date formats. So it's very important to specify, is this the month? Is this the day? Is this the year? It's very important to specify the units because otherwise you might end up with swap dates and that can cause problems. So this is just specific patient information, so we don't need to fret about that. But again, here we have the birth date. So again, being very clear, month, day, year. And then, so these are other demographics. So one thing you'll notice for gender, it's not a free text field where you can write down male, female, or so on. It's check boxes where you check off male or female or unknown. And this CRF has a clear instruction, check one, because for gender, or let's say sex, there can only be one or the other, right? So it's important to specify clearly, only check one. But with some fields, like for instance, race, it can be of multiple races. So again, it's, certain check boxes and you can indicate, okay, check all that apply. So in this CRF, we have, pretty much no free text fields. So whoever is recording the data has to pick from one of the existing categories. And then also just a clear instruction, check one, check all that apply. Here's an example of a CRF for vital signs. So again, at the top, we have the the relevant subject information, and then kind of clear check boxes, pretend this is visit 1, 2, 3, whatever. And then a big one. So now this is really going into units. So again, there's no consistency across the world about what units are used. I know most of the world uses centimeters, some of the world uses inches. So it's just important to be very, very clear with the units. And then notice these little check boxes for height not measured, weight not measured. So basically this allows us, if we were to go back and check why is this data missing, we can actually see, oh, that it actually wasn't measured rather than, oh, it wasn't entered into the database. So just kind of having these things up front minimizes the need to having to go back and forth and check. And then everything else, as you can see, is fairly straightforward. So we have, the time, specify 24-hour formats, temperature, specify Fahrenheit, and there's also a nice little checkbox for temperature not measured. And everything else is fairly straightforward. When possible, when applicable, the units are specified. For these little check boxes, we see, okay, check one. And yeah, so this is an example of a very clear CRF because everything is, explicitly defined. And it also has these little measures to ensure, okay, the height actually wasn't measured and so on. So here's just a quick side-by-side comparison of a poorly designed versus a well-designed CRF. So basically the well-designed one is what we've sort of saw in the previous two images. But the poorly designed ones, we can see, okay, data visit, just a free text. So one person may write 1st of April, 2010, another person might write 2010, so basically different people enter it differently. And then when it comes time to analyze it, it just gets messy. And I'll illustrate how this gets messy later on. Things like blood pressure, there's no units specified. Pulse, no units. None of these have any units specified. So it can cause confusion when you're collecting the data and you're thinking, for pulse and respiration is probably the per minute is pretty common, but temperature, Celsius or Fahrenheit, it's not obvious. So just make sure your CRFs are as obvious as possible. So just some general principles for an effective CRF design. So ensure that the CRF follows a logical sequence that mirrors the clinical flow or timeline of care. So, have visit 1 information at the top of the CRF, and then the next one can be visit 2 specific. So keep questions and instructions short, clear, and unambiguous as possible. So use mostly closed-ended questions and include an other specify option when necessary. It's recommended to collect the raw data, for instance, the date of birth instead of age or the weight/height instead of BMI, because we can use, so for instance, with BMI, so if we only have BMI recorded, but for whatever reason we need to go back and look at their weight, we can't do that because, if we're missing the weight and height, we can't go back and calculate it. So it's always recommended to calculate or collect the, kind of the raw data and then after do the calculations. So always specify the units for biological measurements. Define clear options for missing data, so for instance, unknown or not collected, and limit free text fields to essential contextual notes. So another thing to consider, or another thing that is recommended, is to establish clear CRF completion guidelines. So you should consider which fields are mandatory versus optional. Not all fields may be mandatory. Um, Also provide instructions for how to handle missing or incomplete data and maintain consistent terminology when applicable. For instance, one person might say rash, one person might say skin eruption. So having kind of a predefined list of terminology would be helpful. One thing that I think is important is the design and the review of the CRF should involve the entire study team. So the investigators, clinicians, data managers, statisticians, and so on, because this ensures that people from all aspects of the project are able to shed some insight. And it also helps ensure that the data are relevant, analyzable, and also practical to collect. It's also important to pilot test the CRF early in order to identify potential sources of confusion, redundancy, or missing fields before the data collection actually begins. Okay, so I understand we're to include a few multiple choice questions. So here is the first multiple choice question. So here we have just a quick example of a CRF that I've put together. So which CRF item do you think would most likely cause inconsistent data entry? So would it be the systolic blood pressure, a numeric field, smoking status, a checkbox, patient comorbidities as a free text field, or treatment arm as a checkbox? So I'll give it about 30 seconds.
I think I have a different first question.
Oh no.
Yeah, just a second. Let me check. Um, so we'll just do choice A, B. Sorry, let me make it quick. D. So I launched it. I apologize. Okay, so we'll wait until 80% answer. Get a little bit more answers, please. Okay, I'm ending the poll. Excellent. 80% answered. So I'm ending the poll, sharing results. So majority answered A.
Okay. So actually, well, I mean, I suppose it's a bit of a subjective question, but I would argue that the answer would be
Mhm.
C because it's a free text field.
Mhm.
Um,
Yeah, maybe they didn't understand. I didn't have a translation. I
yeah,
apologize for that. Yeah.
that's okay.
Mm.
So I'll illustrate why C can be problematic. There we go. So let's say for patient comorbidities, it's a free text field, so anybody can just type in anything. So what
Mhm.
will happen is you'll end up with data that looks something like this. So you can end up with this data will be very difficult to analyze. So for instance, patient 01, they have DM, HT, and CAD. Well, what exactly does that mean? Can be a little bit tricky. And then you just basically can see there's a lot of inconsistencies. There's a typo here, it's a question mark, so we don't really know what this means. So what will happen is, for us to describe the comorbidities of this group, if we have hundreds of data of patients with data that looks like this, it's going to be very difficult to turn this into meaningful categories. So instead, what would be recommended is to have checkboxes with predefined categories, allowing for multiple comorbidities to be selected. And if necessary, include a free text other category. So for collecting comorbidities rather than, anybody writing down anything they want, here you have clearly defined checkboxes. And if you want to collect other, specific, details of other comorbidities, you can certainly add a field to do so, but then just be aware that the data might look something like this, which becomes just difficult to analyze and interpret. Okay, so the third step is the database conception. So we have a research question, we've developed the CRFs. So based on this, what will our database look like? How will it be organized? So a database is built from one or more tables. So each row represents a subject or a record or a patient. Each column represents a variable or a measurement, and I'll give some visual examples of this shortly. Then you choose an appropriate platform. So there's many out there, but commonly used ones are Microsoft Access and RedCap. Metadata is also fairly popular, but it's quite expensive. So I know not a lot of people use it anymore. Now you might be wondering, well, what about Excel? Excel, like Microsoft Excel, it can be used for smaller projects, but dedicated tools like Access or RedCap have some very significant advantages that I will talk about. Um, Sorry, they have very significant advantages. So the first is that it's centralized and secure data storage. It's stored onto a single server. Um, there is support for multiple users with defined access rights. There's built-in audit trails and query functions. And the last one I want to take a moment to highlight is the ability to link tables through relational table design. So this is ideal for studies with repeated measures. So if you have multiple measures, say like multiple chemotherapy doses and whatnot. Let me show you how, if you put all the data in Excel, it can get a little bit messy. So let's say we have a data of patients treated with radiation and chemotherapy. So spreadsheets like Excel files are useful when there is a one-to-one correspondence of data. So here we have the demographics, we have our MRNs, their date of birth, name, death day, and so on. So for things like this, Excel works quite nicely, but things start to break down when you have one-to-many correspondences. So in this table we have our MRN, but then each patient can have multiple radiation doses basically. And then so for each one you need a different row to denote all the details. And if we were to combine the information from table A and table B, we get a big mess like this. So if we wanted to put all this information into a single spreadsheet, we have a lot of duplicate information. So everything in red is redundant, basically. And so this can mean our Excel spreadsheet balloons in size, but it also means that if we have to fix something, it's very, very prone to error. So let's say that MRN 12345's date of birth is actually 1910, not 1900. We would have to correct all of this information here. And as you can imagine, if you're doing that manually, it's very easy to accidentally, make a mistake. So this is where relational tables, relational databases can come in very handy. Basically, in something like REDCap or Access, you have different tables, each containing different data. So for instance, we have, with our previous data, we have, say, a demographics table, the treatment course table, and the chemotherapy table. So, and what's important is that we can link all this information to one another. So we can link the demographics table with the treatment course table on MRN. And then we can also link, so let's say patients can have multiple doses of chemotherapy per radiation dose, basically. We can link the treatment course table with the chemotherapy table on MRN and treatment course. So this kind of relational database design has a lot of flexibility, especially when you're doing larger studies with, multiple treatment doses and whatnot like this. So the next thing to consider is there's a handful of ways you can organize your tables. So there's two common organizational strategies. The first is a sequential design. So you structure your tables into chronological blocks. So for instance, you have a table for day one, information, day two information, and so on. Another way you can structure your tables is a sort of a thematic approach. So you can structure your data into by theme, basically. So demographics, prior therapy, medical history, and so on. A database, like a full database, will probably have a mix of the two. Okay, so the second multiple choice question. So say you're creating so you have a database that has both a demographics table and an adverse events table. Which field must appear in both in order for us to be able to link the data and do a proper analysis? Okay, so we're at 85, 90%.
85, yeah.
Yeah.
So I'm ending results and ending the poll and sharing the results. So most 72% answered B, subject ID.
Yep. So that is the correct answer. So let me just close that. So, right, because subject ID, this is something that's unique to each patient, and therefore it's key for connecting a participant's, it's key for connecting the two tables. Things like age and date of birth are not necessarily unique. It's unlikely that you'll have two patients with the same date of birth, but it's not impossible. So date of birth alone isn't a sufficient unique identifier. And age too, it's likely that you'll have patients of the same age. So that is not a sufficient unique identifier. So So when you have multiple tables, it's important to describe or at least think about how they're going to be linked to one another. So here's just a very basic example. So say we have sort of similar to the example I showed earlier. So say we have demographics, the treatment course, so the radiation information, and then the chemotherapy information and adverse events. So we would want to be able to, obviously we want to be able to link all these tables together by the subject ID. So we can figure out, specific demographics that had this adverse events and so on. So this allows us to link everything together. But we may want to go a little bit more in depth than that. So this is just a basic, this is just one example. So let's say we want to be able to link well, no, we want to be able to link so chemotherapy to the treatment course. So we want to know that, okay, this chemotherapy dose 1, 2, 3, 4, 5 was associated with, the first treatment course. So that it's important to ensure that we're able to link the data sets that way. And then similarly, we want to link, you know, everything else that way. And again, this is just an example. Your kind of schematic might look different, will probably look different based on your research question. And then similarly, say we want to be able to, so, so say we've collected adverse event information specific to chemotherapy doses. If patients can have multiple chemotherapy doses, we need to ensure that we can link the adverse event with the chemotherapy dose. So it's important that both the chemotherapy table and the adverse event table also has a chemotherapy ID. So again, this is just a basic example. It'll look different for each project, but just something to keep in mind when you're developing your database. Ensure that each table has the necessary identifiers so that you can link the two. So another thing that is important is the defining the data dictionary. So this is a very important document that explicitly defines every variable in the database. And this ensures that everyone entering, cleaning, and analyzing the data speaks the same language, so to say. And I'll give an example of this in the next slide. So there's several things to there's several components of a data dictionary, so things like the variable name in the table, a clear label or definition, what table it appears in, anything specific to like formats or units, allowed codes, range checks, and missing data rules. That's a lot of information, so let me give a quick example. So the data dictionary is basically a document that looks something like this. So you have your variable name. So this is how it appears in the table. The definition, what table it appears in, the type of data. So a subject ID is a text, date of birth is a date, any specific details about the formats or units. So you can see that it's not always applicable. And things like the coding structure. So here's an example. So for instance, sex is coded in the database. 1 is male, 2 is female, and 9 is unknown. Anything specific to, rules and whatnot, and I'll talk a little bit about this later. And anything specific to the missing data rule. Now, the nice thing about using REDCap is that, from my understanding, REDCap will nicely build this data dictionary for you that then you can use for the entering the data, analyzing the data, and so on. So that's also why REDCap is a really good tool if you're going to be building a larger database. Okay, so now we're on to step 4. So we've spent all this time thinking about how we're going to build it. Now let's actually build the database. So of course the process will depend on what tool you're using. So whether it's Access, REDCap, metadata, or so on, but all of them have pretty, user-friendly ways of building databases. So when you're building your database, you need to consider several basic structural issues. So first you need to ensure that each participant is assigned a unique ID. If there are several records per subject, ensure that the database should contain 1 record per measure for the subject. So for instance, if a patient has multiple adverse events, make sure that there's a separate record for each adverse event. Each should be identified, so each separate event should be identified with a unique record ID, so like adverse event 1, 2, and so on. And ensure that IDs are set up to allow linkage across tables. So for instance, in the example I gave before, ensure that the tables have, the treatment course ID, the chemotherapy ID, and so on. And then while you're building the database, you're going to use your CRF and your data dictionary. You're going to be referring to these closely to determine the data type. So if it's numeric, character, or so on, and also the field type. So whether it's a checkbox or a free text field and so on. And a couple things that I don't think is frequently considered is how missing data will be handled. So a common one is dates. So let's say that you're talking to a patient or you're collecting data on a patient, they were diagnosed, 10 years ago, they don't remember the exact date. But if when it comes time to analyze this, we can't analyze, a missing date. So it's kind of important to, at the get-go, specify rules for what will be used in its place. So let's say that, the patient knows they were diagnosed in March 2020, but they don't remember the exact date. So when you're building your database, you can specify rules so that if the day is missing, you can enter the 1st or the 15th or whatever. I think the 15th is the most commonly used, but the 1st is also valid. Again, it also depends on your research, on your kind of study design and research question. And then also come up with rules if both the day and month are missing, and specify in advance if the month and day are basically what you'll replace the month and day with if they're missing. Because otherwise, when it comes time to analyze the data, I see a bunch of unknowns and I'm going to come back and ask you, how do you want me to analyze this? How do you want me to handle this? I can't enter a blank date or an unknown date. So it's important to come up with these in advance. Another thing to consider is, that you should do is develop edit checks. And I'll discuss this more in step 5. Just really quickly to wrap up the database building. So think about confidentiality and security considerations. So ensure that your data are stored on secure access controlled servers. Create logins and passwords as needed. So think about who's going to be managing the data, entering the data, create the appropriate logins for them, and create the appropriate logins for them. And then you can also assign role-based permissions. So some people may only want, you only want them to have read-only access so they can't edit the data. Some people you want to be able to edit the data, and some need to have administrative rights. So that's something to consider when setting up your database. And also build audit trails of all changes. That way, if somebody goes and changes the data, it's completely transparent that, this change was made, and then you can also find out why it was made. And then also good practice is to schedule regular backups and data integrity checks. And again, REDCap pretty much does a lot of this for you, which is why it's a great tool. Okay, so step 5 is the data validation process. So good quality data, I probably don't need to say this, but good quality data means good quality results, or conversely, as we like to say in statistics, garbage in, garbage out. So now that we've created our database, we've computerized everything, it's all ready to go, we can start entering data. How can we ensure that our data are the best quality? So the first, of course, is compliance with the CRF completion guidelines, which I talked about in step 2. The second is ensuring we have edit checks process, and I'll give some examples of this shortly. And the third is specifying a data clarification process. So specify how queries will be transferred to the clinical site, tracked and reviewed. So what exactly is an edit check? So an edit check is basically a built-in check of the data once it's been entered. So if the data don't fall within, say, a specified range, it can give a warning or a hard block. And I'll give some concrete examples of this. So one edit check that you should build into your database, and again, REDCap allows you to easily build in, is basically prevent impossible values. So one example is, say, apply restrictions on dates to ensure no impossible dates are erroneously entered. So for instance, ensure that when you build your database, you can't allow hospital discharge dates to be before the admission date. So ensure that it must be after the admission date. Ensure that dates are not in the future. It's very easy to, accidentally type in 2026 instead. Ensure that the study enrollment date is before the initiation date, treatment initiation date. Ensure that dates are not implausibly old. So you can build in checks that will automatically flag if any of these scenarios happen. Now it sounds quite straightforward, but data entry there's data entry errors do exist. So by building these edit checks in advance, you minimize the risk of, these errors. And then what'll happen is I have some colleagues that are working on a red cap study where they did not do all these built-in checks. And so now they're analyzing the data. They have, people dying before they're admitted to the hospital, all sorts of crazy dates that now the team has to go back and sort out. And this is just delaying the study, costing tens of thousands of dollars. So strongly recommend, coming up with these checks in advance because it'll ensure you have good quality data, but also that you don't have to go back, years after the data has been collected to double check these things. Another type of edit check is ensuring that your variables, basically you have acceptable ranges to values when applicable, of course. So for instance, if you're measuring height in meters, apply a restriction to a height. So ensure maybe that height isn't greater than 3 meters because this will prevent entries in centimeters. So if somebody enters 150 instead of 1.5, this will flag it. So things like, ensure that systolic or diastolic blood pressures are within reasonable values. So if somebody enters a value of 999 for systolic blood pressure, it's immediately flagged. And also define acceptable ranges for lab values. So for instance, a range of 6 to 20 for hemoglobin. If the value is below or above this, create a flag. And so that way the person entering the data has to double check. And then another one is ensure that age and other eligibility criteria are actually within the eligibility criteria. So if you're, looking at a pediatric cohort and you enter the age of somebody, you enter 25, you want the system to flag, oh, this isn't within the eligibility criteria. Are you sure? And this forces whoever's entering the data to go back and double check. So edit checks can be both hard checks and soft checks. So hard checks are basically hard limits. So the data with hard checks, the data cannot be saved until the issue is corrected. And this should be used for impossible values. So things such as negative age, death date before enrollment date, and so on. And so these enforce data integrity. You can't enter impossible values. Now, things like soft checks. So these are basically warnings. So the data can be saved, but a warning appears. So these are more useful for implausible, but technically possible values. So for instance, a very, very, very high systolic blood pressure or a very, very high weight in kilograms. So it encourages review without blocking entry. So you would enter the data, you would get a little warning saying, are you sure this is outside the range? And this again encourages review, but without, but because these datas are technically possible, it doesn't block, it doesn't prevent you from saving. And it's important to use a mix of both within your database. So this is the next multiple choice question. So which of these illustrate appropriate use of edit checks in a study database? So the first is a hard check, preventing an impossible data sequence, so say death date before enrollment date. A soft check, warning if a lab result is outside the clinically plausible range. The third is a hard check, prevent negative values for variables that can't be negative, or all of the above.
Sorry, I think I have slightly different. Let me see. Sorry about this. For some reason, the polling did not really work very well today. Is it the similar one? Did you change it? Is it similar question?
It looks the same to me. Soft check, bilirubin. Yeah, it looks the same to me.
Okay. Okay, sounds good. Oh yeah, looks good. I entered your questions yesterday and they didn't save, so It's
Ah,
it's the first time it happened to me. But okay, we remedy the situation. Um, I while people are answering, oh, so it's actually 85% already answered. I'm ending the poll, sharing results. Majority, 82% answered D, all of the above.
yes. So, oh, sorry. Yeah, so that's correct. So all of these would be, good examples of edit checks. So again, when building your database, consider incorporating checks like these into your database. It just significantly reduces headaches down the road. And again, improves the quality of your data.
Catherine, I had a
Yeah.
question while you were talking about, let's say if we did not put in any thresholds on answers, and some people answered like using wrong units, thinking it's per year, but it's actually per day. What do you do with this data? Do you flag it? You can go back and ask, let's say the surveys, right, to re-enter the data. But let's say if you don't have this ability anymore, what do you do with the data?
It's hard to like because if we can verify, so yes, of course, like when we do the analysis of the data, if we see that, oh, there's something that suggests it might be different
Yeah.
units, we do go back and flag, is this data correct?
Hmm.
Like for instance, I've gotten the height one pretty frequently, right? Somebody entered it in meters and centimeters. So sometimes we will go back and say, can you please verify? And in the vast majority of cases, they can go back and say, oh, sorry, we got the units wrong. So then
Hmm.
what happens is the database is yeah, so the database is corrected, and then
Hmm.
we obtain an updated database. So that's usually like what happens.
Okay.
Yeah.
But you cannot just assume and correct it without their confirmation, correct?
It depends. So like I said, with some scenarios like height, it's very obvious.
Yeah.
Like the centimeters to meters. So like we can like, certainly like kind of as an ad hoc thing, we can do it.
Hmm.
But typically you would also want it to be corrected in the database anyways, right? Because if it comes time to do some more analyses later, it's good to correct the database.
Okay. Thank
Yeah,
you.
no problem. Okay, so I'm going to provide a very, very quick introduction to REDCap. So what exactly is REDCap? So REDCap is a research electronic data, it stands for Research Electronic Data Capture, and it has a nice little cute red cap in its logo. So basically, it's a web-based application for building and managing online surveys and databases. So in addition to databases, it can also be used for surveys. So while REDCap can be used to collect virtually any type of data, it is specifically geared to support both online and offline data capture for research studies and operations. So there's a lot of flexibility for how the data can be entered, or data can be collected or entered, which is why it's fairly attractive amongst, in clinical research. And a nice thing too is that it scales easily from, say small pilot studies to one clinic to multi-center projects because it's all online. So, all you have to do is give different users from different institutions their own login. So it's quite flexible in that regard. So there's several key advantages. So REDCap is browser based, so you can just access it online. You don't need to do any sort of coding for the setup. It has an intuitive CRF and survey builder, which, sorry, it has an intuitive CRF and survey builder. Like I said, it supports both single-site and multi-site studies. And it also has built-in project templates for common research designs, which, makes designing things at the beginning a lot easier. Um, it also has several built-in data quality and integrity checks. So it does have a lot of, automated range and like logic checks at data entry. So kind of it has a lot of those edit checks that I was discussing earlier, but of course, be sure to add your own because not all of the built-in ones may, have everything you need. It has real-time validation to prevent common input errors. It has tools for easy data dictionary development. So once you kind of design design your tables, design your, figure out what variables you want in each. It nicely creates a data dictionary for you. Um, and also a big one is that it's easy to export the data for analysis. So it can spit out data that is SPSS friendly, R friendly, SAS friendly, and so on. So that's really nice. It means a lot less cleaning afterwards. So there's also one thing is several security and compliance advantages. So you can select different permissions for different users. So some only have read-only, some have administrative access, or they can edit everything. So it makes selecting that nice and easy. There is secure authentication and encryption, which is important for, ensuring the data stays secure. You can also get really granular with permissions, so you can specify, perhaps only certain number of people can edit this specific field. So there's a lot of flexibility that helps protect the data. And then a very important one is that there's an automatic logging of every single data change. So if, data entry clerk 2 makes this small change to the data set, it is logged. So this is really important in ensuring, kind of the quality of the data. So that's all I'm going to talk about for REDCap, because otherwise I'll be talking for another 2 hours. But the MD Anderson group has an excellent lecture on REDCap. So I've provided the link there, and I encourage you to check it out if you really want to learn, get into the nitty-gritty of REDCap. Okay, so I'm going to spend the rest of the talk talking about building databases in Excel, because very commonly, if your study is not huge, where you're comparing, across multiple sites, you don't have a million treatment-related data points to collect. Excel can be a reasonable alternative. It saves you from having to build the database from the get-go. And also Excel is widely used because we all have access to it. We all know, how to enter data into it. So that's what I'm going to spend the rest of the talk discussing how to make a nice database in Excel. Because it's very easy to make mistakes in data entry that will result in problems during analysis. So with Excel, we can't really build in those nice edit checks. So I'm just going to provide a few guidelines for best practices for creating databases in Excel. Now, why is this important? So this is because the software used by statisticians to analyze data, so things like SAS, R, SPSS, and so on, they read an Excel file differently than a human. So what looks nice to a person can be very confusing or uninformative to a computer. It can be, tempting to have colors and all sorts of pretty headers and whatnot in our tables, because it looks nice to us, but a table will not be able to make heads or tails of it. So in clean computer-friendly structure, data structure at data collection will save hours and hours of reformatting and error checking later. And I'll give some examples of that now. So just a quick kind of general guideline. So, the tables will look similar to the tables in like a big database in REDCap. So each row is one record or patient, each column is one measurement, and each row has a unique identifier. So here's a very basic example in Excel. So we have our patient ID in the first column. Each row is a unique patient, and then each column has a different metric. So one thing that is commonly done in Excel tables is merging cells. So for instance, this patient has, this is treatment course 1 and 2 for patient 1, 1, 2, 3 for patient 2. Sometimes people will merge cells because, it looks nicer, it's cleaner. But what will happen is when you go to import this into a statistical software, the cells will unmerge because, the merging is only happening in Excel. The statistical software can't, process these merged cells. And then as you can expect, this will cause problems in the analysis. So when you're creating a data set in Excel that's going to be, analyzed using statistical software, ensure that no merged cells are present. So just with our example, so the solution to this is quite easy. So rather than having the merge cells, just in each row indicate it's subject 1, 1, 2, 2, 2, and so on. Another common one I see is keep only one row for variable names. So again, something like this might look nicer, and it does actually look pretty nice, I'll be honest. But what happens is by default, statistical software will assume that the variable names are in the first row. So that's this row up here. And then the data begins in row 2. So then when this is imported into a statistical software, okay, the first column name is blank. And then something, goes a little bit funny here because we have merged cells and so on. So instead of having things that, a table that looks like this, what you should do is make sure that the column names are only in the first row of data, and then use like say suffixes or prefixes in order to distinguish between, the different time points. So here, instead of, having at baseline at the top biomarker here, have, biomarker underscore baseline, stage underscore baseline, biomarker underscore post-operative, and so on. So what this does, it saves you from having to, combine this information later, and it's all nicely identified for you. And each of these variables, like again, although not pretty, these are distinct and they're also very meaningful. Okay. The second is, so here is an example of an actual data set I received, and this is fairly common. So people basically put the details of the coding in the column name. So, what happens is when you go to import this data set, you end up with column names, diagnosis underscore underscore 1 underscore underscore, and so on. And then you just have to, this makes you have to go back and rename everything. So please don't do this. Instead, what you should do is something like the following. So basically have a separate data dictionary sheet that has your variable, a description, and also all of the values. And then in your actual data sheet, you would just have, just a diagnosis, so you take out all the details, and then same here with comorbidities. Take it out, have it, and then this just gives you a very nice clean data set. And also having a data dictionary in an Excel spreadsheet does have many advantages. So of course, the first one is that long variable names make the data cluttered and therefore more difficult to read. So let me just quickly go back to this example. This is, it's challenging to read, and just imagine a big data set with many rows like that look like this, many columns that look like this, many rows of patients. It just becomes difficult. The data set just starts to become messy. The data dictionaries also allow explicit variable definitions. So say, for instance, you're collecting smoking status. You can add a label, so you can create your variable name can be called smoking underscore status, and in the dictionary clarify smoking status at baseline. So rather than having a long smoking underscore status underscore at underscore baseline, you can just say smoking status is the variable name, and then in the dictionary clarify that it's at smoking status at baseline. Also, taking the time to create a data dictionary with specific coding ensures that your coding system is well thought out. So for instance, let's quickly go back to this comorbidity list here. So this group took the time to come up with clear categories. So when they were collecting their data, they decided in advance, okay, we want to know who has these specific categories. So kind of putting this forth, that will make, once it comes time to analyze the data, just a lot more straightforward. It also reduces data entry errors, and this is especially when multiple people are entering data into a single spreadsheet. Another advantage is if a new category is added, it's much easier to simply update the dictionary and add this new column and add this new category rather than go back and rename the column. So let's say we wanted to add an eighth comorbidity. All we have to do is update the data dictionary and then we can, and then it just makes entering that much easier. And so all of this really facilitates efficient statistical analysis. So if we don't have long column names, we don't have to waste time renaming everything. The consistent coding ensures that time spent reformatting variables before analysis is reduced. So we don't have to go back and manually clean everything, double check is everything spelled the same way and so on. And this also ensures consistency in coding. So for instance, if you have multiple people entering data into a spreadsheet, one person for sex might write only M or F, might write male versus female, like the full word, one might do it in all caps. If there's no consistency, you might get, things like that where everyone's entering data incorrectly. And this will all need to be cleaned up at the analysis stage. So I just wanted to take a quick moment to discuss some column naming guidelines. So the first is to keep names concise and clear. So use short, self-explanatory names. So things like weight underscore kilograms, that's easy, it's weight in kilograms. Or things like visit underscore date. Avoid overly long labels. So because they clutter data sets and will often need renaming for analysis anyways. And if if you have a variable name but you need to be, explicit in its definition, just use a short name and then clarify the full details in the data dictionary. Another big one is use consistent machine-friendly formatting. So sometimes spaces and special characters, so basically anything in the brackets here, can cause problems when it comes time to analyze the data. So it's recommended not to use these. So it's recommended to stick to letters, numbers, and underscores. So for instance, patient underscore ID, not patient place space ID. It's not the end of the world if you have spaces, but it's just considered better practice to use underscores instead of spaces. And also just for simplicity's sake, maintain consistent case. So for instance, all lowercase or all uppercase and so on. As long as you're consistent, it'll make, the analysis smoother. And of course, make sure you apply standard naming conventions. So, if there are standard abbreviations, you can use like say SBP, COPD, CHF that are universal, use those. And if you have, say related variables, like for instance, we were looking at the underscore, when we're looking at stage and biomarker at baseline and post-op, we use the underscore post-op to indicate those. So yes, it's just recommended to group related variables with a common prefix or suffix. And make sure you're consistent. So, do visit one dose, but then don't do visit underscore one underscore age for another. We get that a fair bit where the kind of prefixes and suffixes are not commonly applied, and it just makes for messy cleaning later. Okay, so the fourth multiple choice question, which column header best follows the column naming guidelines I introduced in the previous slides?
I actually looked up red cap use in Ukraine. 19 institutions are using it, so that's great. I think the license was free during the war, so I think I would encourage everyone to look into it. If you are running a study and then you have complex information, patient charts, I think it's great to use red cap.
It is a really great resource. We use it a lot at like Princess Margaret Hospital or University Health Network. And the nice thing is that there's users all across the world. There's a big like online
Right.
consortium. So there's a lot of resources that you can tap into.
Yeah. Yeah, we use it at Stanford quite a bit. Okay, so we have 90% answering. I'm ending the poll, and majority answered C.
Yes, so C is correct. Sorry, there's a little bit of a lag. There it is. Yeah, so C is the best because it has, so there's no spaces, no punctuation, and it's compact and clear. A is problematic. The parentheses can be problematic, and there's also spaces, which is not recommended. B is just very, very lengthy. It's not necessary to be that lengthy in your variable names. And then here H slash, and then D has the slash in it, which can cause problems in analysis. Okay, so just a few more kind of, tips and tricks for how to basically have the best data, Excel database possible. So another tidbit is do not store multiple pieces of information in a single cell. So let's say you have a group of patients where patients can relapse multiple times. You might be tempted to enter the data like this. So patient 1 had only 1 relapse, but patients 2 and 3 had multiple, and then you list the dates. What will happen is when it comes time to analyze this, the statistical software will not know how to make heads or tails of this data, and therefore this will be kind of treated as a categorical variable. You'll have to go in, parse it out, and so on. So it's just extra work. So instead, what is recommended is to create multiple columns, one for, first relapse date, second relapse date, and so on. And in scenarios where, say, patient only had 1 relapse, you just leave relapse date 2 blank. So this way you have kind of nice, clearly defined dates in each column. Another one I've seen fairly frequently is, say, again, for the relapse information, in the relapse date column, you have, the first patient, they didn't relapse, so you write no relapse. And then the second 2, they did relapse, but as you can see, it's not quite labeled consistently. Here they wrote relapsed, here they wrote relapse. And I know this seems fairly minor, but then when it comes, if you have hundreds of patients, to kind of separate this out, it's easy to make a mistake, especially if, different people are entering the data differently. So what is recommended instead is, again, just separate the information. So create basically a relapse indicator to indicate yes, no, they've relapsed. And then if they have relapsed, enter the date. If not, just leave it blank. Okay, so another one is to be consistent with date formats. So again, this is a massive problem in Canada. We can't get our dates straight to save our lives. So choose your date format in advance. This way it ensures that when you're entering the data, you're entering it consistently and you're not changing the date halfway through, because then you have to, when it comes time to analyze the data, you have half in one format, half in another. And statistical software isn't smart enough to detect, what's what yet. So it's important to specify in advance what format you're going to use. And we recommend spelling out the 3-letter month because it completely eliminates the ambiguity. So for instance, just kind of an example for an ambiguous date, we have 01/02/2010. Is this February 1st or January 2nd? Again, in the States, they use month, day, year, but in Canada, we use everything. So if I were to look at this, I would have no idea what the exact date is. And one thing is when you're entering data, make sure you specify the 4-digit years. Some people might enter, just the last 2 digits. So like YY-MM-DD. But what can happen is if you don't specify the first 2 digits, you might not get the first 2 digits you're expecting. So if you were to go right now and enter 27-12-12, you would have a date in the future, December 12th, 2027. So just something to keep in mind. So here's just a quick sort of side-by-side example of a data with good date format. So we can see that it's consistent. And we always have like the 4-digit year, the 3-letter month, and then the 2-digit date. Here's a bad example. This is actually copy pasted from a data set I received. And you can see there were multiple people entering the data and they were not consistent. And then so what this means is I have to go on a case by case basis and figure out, okay, what's what? But in certain scenarios, you can't even figure out, is this September 9th or September 8th or August 9th? So it's just very important to be consistent with your date entry. Now, one tool that is very helpful for in checking to see that you've entered your dates correctly is the filter function in Excel. So if you've done it correctly, you can nicely filter your dates by year. So I'm going to quickly open up, oops, come back here. So this is just a very, very, very simple data set I've created to help just illustrate, help basically illustrate this. So what you do basically, so to get to the filter tool, you go at the top to data, and then here there is the filter button. And so quickly, I just want to compare the good date and bad date, as I cleverly called it. So for this good date, so we see that everything has been entered consistently. And if we were to go and look at the individual dates, we can see that, okay, they're all sort of nicely organized here. Excel is recognizing them as dates because we can go to, okay, 2021, June 1st, and so on. So we can nicely sort of collapse, we can determine that Excel has correctly identified these as dates. Now, what about this example where you can see it's just hideous dates? We see that, okay, some of them have been recognized by Excel, but not all of them. So Excel doesn't know how to parse this one or that one, and so on. So this is just a good way of quickly checking, have I entered my dates correctly? Now, the filter tool is also really useful for other things. So let's say so you can see with sex, it's all, entered pretty inconsistently. So with the filter tool, we can quickly see, okay, these are all the possible values we have in sex. So we have, again, well, I made this one intentionally bad, but we see that, okay, in sex, we have values of 1, F, female, M, male. So this allows us to see, okay, these are the values we have. We should clean it up, basically. And then similar with things like, death here. Okay, these are all the values we have in our table. These are all the values for treatment we have in our table. And I know this seems really goofy, but I have received data sets where radical prostatectomy was spelled 10 different ways. So again, strongly encourage you to use different, just kind of a more structured coding process because it just eliminates, the statistician or anyone having to go down the road and clean it all up. Okay, let me quickly go back to the slides. Another quick thing is don't mix character variables with numeric variables. So let's say we have this example here. So we were looking at CA 125 at diagnosis. We don't know this patient's exact value. All we know is that it was greater than 19,000. So, we enter 19,000. Now, greater than 19,000? So what will happen is statistical software will interpret, because there's this little character symbol here, it'll interpret this as this whole column is character, and then you have to go and clean it up after. So don't enter data like these because what will happen is if you want to calculate the CA 125, I'm going to come back to you and ask, how do I analyze this? This isn't a number. What do you want me to do with it? So it's important up front, if you can't specify an exact value, either leave it blank, so just we'll call this one missing, or replace with something plausible. Again, it's a case-by-case basis. It depends on what makes most sense for your data. Sometimes you may end up with a value within a range. So let's say CA 125 was between 2 to 4. In scenarios like that, consider entering the mean, the average, or some other clinically plausible value. So again, it's important to do this upfront because otherwise, like I said, the statisticians will be coming back to you and asking, What do you want me to do with this? So it's important to make that decision up front. Another one is, unfortunately, colors are not interpretable by statistical software. Sometimes you may want to use colors to classify patients according to, let's say, treatment group, but unfortunately, statistical software doesn't recognize colors, and this information will be completely lost. So instead, what you should do is just add a column indicating the groups rather than using colors. Don't have any blank rows or columns. So statistical software will automatically import everything up to the first non-missing row and non-missing column and non-missing row. And this can cause unexpected results, when it comes time to do analysis. So it's just good practice to keep your data compact and continuous. To me, this is a big one because statistical software will import all hidden rows or columns. So sometimes you may decide, so in Excel, you can hide columns, but all this does, it hides them from being visible in Excel. It doesn't actually delete them in the statistical software. And then so sometimes I've received a data set where they've hidden rows, excuse me, so in these hidden rows are patients that they don't want me to analyze, but they do this without telling me. So then what happens is the statistical software doesn't know that these rows are hidden. And then so I end up including patients that should not have been analyzed because again, hiding doesn't do anything. Hiding doesn't remove them, it only hides them from sight. So if you have any rows or columns you don't want to be analyzed, just delete them. Do not hide them because that will not, take them out of the analysis. Okay, so I'm nearing the end. So just some general guidelines to wrap up what I've discussed. So in Excel, when you're developing a database, and a lot of this is similar to kind of the broad level larger databases I was talking about in the first half. But so ensure that only the first row includes your column names or your variable names. Ensure that each row has a unique identifier, so your patient ID or your sample ID, whatever. Make sure you have no blank rows or columns. No color coding in the spreadsheet because it will not be interpretable. Do not hide any unwanted rows or columns, and ensure that each cell only contains one piece of information. So, don't combine yes, no relapse with the relapse date. Have everything separated out. Ensure that your dates are entered consistently. Ensure that your data are entered consistently. So it's encouraged to use coding when possible. That way you don't end up with tables that look like the little kind of sex table I had earlier with male in one and M. Using a coding structure minimizes that. If coding is not used, make sure your data are at least entered consistently. So for instance, we have, if we have a category of MM plus PV, a statistical software will interpret MM space plus space PV versus the same without a space differently, and that will have to be cleaned up later. Don't mix character data with numeric. So if you have, say, a numerical value that is within a range, either replace it with something plausible or just leave it blank, and ensure that a data dictionary is provided. Okay. And the last multiple choice question is, so kind of just a summary of everything I've talked about. So what's the main reason to design your CRF and database thoughtfully from the start?
Thank you, Catherine, for going through all the possible mistakes. I probably made all of them. Thank you for telling us what not to do. I really
Yeah.
love colors, and I hide cells and rows and columns. Yeah.
Yeah, it's very easy. I think because like if you're not aware of what, the data looks like when you
Yeah.
start to analyze it,
Mhm.
it's hard to really appreciate it. So I'm glad, I'm hoping that this provide a lot of practical
Thank you.
tools.
Definitely. And so sometimes we think about a little bit more the ease of use for the person actually filling out the survey rather than the person analyzing the survey, right? So we want to make it easy, let's say multiple choice question, right? But it puts the comma, right? Separates the answers and puts everything in one cell, but it's difficult for a person analyzing actually do the analysis.
For sure, yeah.
And
No,
there's a
mhm.
balance, right? So you want to make it easy also for people filling out the survey because they don't want to spend so much time filling this out, right?
Of course, no, I completely appreciate that. Yeah.
Mhm.
But yeah, I definitely think, spending just a little bit more time just upfront, just having kind of a clean, database, sort of clearly define what you're going to look for, how you're going to categorize everything. I think a little bit of initial work upfront will just minimize, significantly reduce the headaches later.
Yeah, definitely. So we have 82% answering, amending the poll, sharing results. So majority said D. So hey, hooray, 93%.
Yay. So there we go. Yeah, so basically, I've probably said this many, many times, but spending time early in a study to design robust data collection methods and database structure pays off later. So it produces higher quality analyzable data, reduces costly cleanup, both from a statistical point of view, but also the data entry clerk point of view, having to go back, and it helps projects stay on schedule. So I've provided a few references for that are specific to creating databases and whatnot. So I encourage you to check those out if you're interested in learning more. And also, like I said, the linked REDCap lecture by MD Anderson is also quite good. And even just the REDCap website is very informative as well. So I encourage you to check those out if you want to use REDCap in your studies. And that's everything from me. Thank you so much.
Oh, thank you so much, Catherine. Bravo. Thank you for going over the database design. It was very, very useful. As I mentioned, it tied together like what not to do and how to think in advance, how to make your data robust and reliable, right? And easy to analyze. So thank you. Thank you for this great lecture. We'll encourage people to ask questions. I see Dr. Shapil, you want to ask a question?
Uh, Hello everyone, thank you very much for very interesting and useful lectures. Now we some our centers in process for collect data and analyze this, and I think it's a little bit hard process because very difficult choose the important data and separate the second data. And I have some questions. I understand if we collect some statistic data as numbers and other, it's more simple. But if we need separate for clinical data, for example, when we do some researches about clinical cases, uh, frequently patients have a lot of difficult additional diagnosis, for example, additional problem with health, and also how we may separate more important data and secondary data, because sometimes it's hard to choose what parameters we must take in our researchers
Mhm.
for no as some importance of parameters.
How do you
And
prioritize what's
yes,
important?
how prioritize some parameters, and after this collect other no,
Important.
secondary parameters surround of this.
Okay, that's a great question, Catherine.
Yeah, for sure. So, yeah, I guess I'm just kind of thinking. So, because I know sometimes, like you said, these fields might be too um, not granular, they might be too specific. Like I said, sometimes you might want to have more of the details. And that's why I think in scenarios, so I kind of alluded to that here. So you can have like in some of the, as you're collecting data, have the opportunity to, or sorry, allow yourself to have like these fields where you can specify all these detailed notes, right? So they may not be useful for the statistician, but like you said, if you're doing kind of, more detailed, kind of case by case, you still have this information available to you. Just kind of keeping in mind when it comes time to like at first statistical analysis of a big data set, it'll be difficult, but for you as a clinician, it's very useful. So you can certainly mix the two. And I think to help decide what's, kind of how to figure out what's important to collect, I think that's why, again, my bias as a statistician, but get the statistician involved early in the study because we can tell you if this is your question, you'll need to collect this data. So we can provide insight as to, kind of, what information you need and how you should collect it. But then also one thing, yeah, so then, yeah, so as you're kind of putting together your research question, just think about, okay, well, I want to do this analysis. What do I need? So I think, like I said, of doing kind of the initial thought at the beginning and then also bringing on a statistician would be really helpful at the beginning. But then
And
also allow flexibility to take these detailed notes if you need them.
And I think it's a good idea to collect more data maybe than you need. If you
Yeah.
have a hint that you might need this and not completely sure, include it. It's better to have more data and then don't use it at the end than missing some data, important data.
100%, yes.
Thank you,
Thank you very
Dr.
much.
Shepard, for the question. Thank you. Any more questions from the audience? Well, people are thinking about their questions. Help Ukraine group, our group is doing a lot of surveys of Ukrainian radiation oncology community, and then we are running these surveys bilingual, so English and Ukrainian. It's challenging to analyze at the end. Is there a maybe formal, more proper way to deal with the multilingual surveys?
That's a great question. I think for questions like that, I'd probably try to limit, like I don't like Likert scale maybe. So do as many like strongly disagree. So maybe having as, I think that kind of goes back to minimizing free text. Of course, free text is going to be essential, but I think as much as you can, if you have the option to do like a Likert scale or agree disagree, I would do that to simplify things. But then otherwise, yes, it becomes kind of a with a free text case by case, okay, did they, what were their thoughts and so on. So that's what I would recommend.
But I also think it's important to include free text because
For
sometimes
sure.
you don't think of, let's say, things they are experiencing, and then it's good for them to let us know that's exactly what they need, for example, for certain questions, right? So we might not think through all the possible answers, right, in some of the multiple choice questions.
100%, yes. No, definitely allow, the opportunity to expand. But I think if you can sort of limit to multiple choice as much as possible, it would simplify things substantially.
Another question I have is about analysis of surveys. So some people, especially if we don't make required fields, right, and make them optional for the ease of filling out the survey, some questions are unanswered. How do you deal then calculating percentages? It's a little bit of goes into analysis of the data, but how do you deal with this missing data and calculating percentages? Do you create like filled out or missing data values for each question and then do percentages based on filled out values? What's the approach?
Yeah, that's what I would do. So I would report how many didn't respond, but then amongst those who responded, break down the percentage.
I see. And
Yeah,
for each
that's
question,
mhm.
right?
For
Because
each question, yeah.
yeah, becomes challenging.
It does become challenging, yeah.
What are the big issues you encountered like, in analyzing the data from your experience, and maybe tell us how you go about, like, have you had to rebuild the whole database because some things were missing, or I'm just curious what can go wrong.
Dates are a big one. Dates are terrible. I've had sometimes, if the data is, yeah, I have had scenarios where the data were so messy, or, they asked me to, from a very long string of characters, determine who had so and so. I have
Mhm.
asked people to go back and say, can you please determine it for me? Because as a child, sometimes I don't have access to the charts, right? So I can't infer
Right.
things. Yeah, so it's not uncommon for the statistician to kind of shoot back and say, I can't figure this out myself. You need to figure it out for me. But that's usually more common in like, smaller Excel databases.
Mhm.
Yeah, so I think that can be a big one, but the dates are a big problem.
Sorry, Canada. Dr.
Yeah.
Serpil, do you
And
have a
yeah.
question? Yeah.
And I want to ask one more questions. If you collect some data with survey, for example, and you data what you take after this, don't compare the data with official source, for example.
Sure.
What
Yeah.
you do in this situation?
So you can repeat the question, compare the data to the official source.
Yes.
Uh,
So there were two
yes.
surveys and then they disagree. One is official, let's say, state report, and the other data is taken, does not agree necessarily. What do you do in this situation?
I would look to see, because presumably it's a different group of people being assessed, right?
Well, same group of people, but maybe,
Oh,
even when you answer a survey, your answers might differ, day by day or minute by minute,
Yeah.
right? You're not the same
Maybe answer not very clear, not very clear who responds on
question,
the
not clear,
survey. Yeah, maybe questions built not very clear, and people who answered give some wrong answer for this. You take some other way how you check this data, or what you must do.
okay. No, because my first impression would be, oh, maybe it's different people answering the questions differently. I would probably go on a case by case basis, for if this question for the survey 1 and 2 are supposed to be the same, but there's a difference. Maybe try to explore what's different, why it's different. Um, I would be curious to see if there's specific groups answering differently. There could be some insight there. I don't know if you have that information available. Um,
Mhm.
that's
Yeah,
interesting. Yeah.
yeah, we even see like same people answering same survey twice, let's say, and their answers are different. So it's quite curious. Okay, I see the question from Nadia Honcharenko. Nadia, would you like to ask a question?
Yes, hello, Catherine. Thank you very much for this interesting lecture. I have a practical question. If we analyze the data from the questionnaires that patients
Hello.
fill in, how do you take the data from the questionnaires that is filled in by hand, like wrote by hand by the patient into the Excel or somewhere in another database program? Maybe you have some tips and tricks, or you just do it manually as we are.
Yeah, if in order for it to be analyzed, it does have to be entered into an Excel spreadsheet. Yeah, so just sort of a similar structure. So each row is each person that completed the survey, and then each column, it could probably just be simple, just do Q1, Q2, Q3, Q4. And then, yeah, I think there's really no choice. You'd have to enter it manually. But I think just having kind of, if you're, at least it's a simple database design. Um, but I'm not aware of any ways to automate that. Maybe in a few years, AI will allow us to do that, but
ChatGPT, you can do that, but if the form contains patient information, that's not allowed.
Mhm.
But I guess if you de-identify, you can maybe take a photo of the form and then ask ChatGPT at least to like put it in a table format, but without patient information.
But you create a survey for every patient and put it into the Excel, for example, or you collect the data every question, like every answer, into some table or something.
Yeah, so you could enter it into like an Excel file. So so each row would be like the responses from one person. So the first column would be like, okay, ID number one. And then the second one would be, okay, this is the response to question one. The second one response to question two, and so on. So you could basically each row would be each person's like survey responses basically, with each column representing a different question. And then that way it's all nicely, combined together.
Yeah, thank you very much. It's just interesting to hear your experience in that because for now we're just collecting the data, and I'm afraid what is going to be when we are starting to analyze all of this. So, thank you for this.
Yeah. I know RedCap allows surveys as well. I've never used it to build a survey, but I know it has the capability. So obviously now it's, you're already in the paper form, but if you're doing, but with RedCap, maybe for a next project, you can develop it in RedCap. You would just have like a computer or a tablet or something where you can enter the responses, and then that way the data is already entered for you. So that is, something you could consider.
And
This program, Red Camp, it's free or it's or not?
I think it's free for Ukrainian academic centers and hospitals. You have to double check, but I would strongly recommend you to go in and check for your institution. And Nadia, you're saying that you are already collecting the survey data. I would go back and see at your data, like look at least few patients to make sure that the data is complete and there are no issues, because you might need to modify the form or just to make sure that everything is validated, and then you happy with what you're getting. And it's good, as Catherine suggested, when you create a form, a database or survey, it's good to always validate it first before you give it to patients. Make sure you're collecting what you need and all the fields are, or questions are not ambiguous, right? It's good to QA things.
Thank you.
Thank you so much. That was an interesting discussion. Thank you for a great lecture, Catherine. We really appreciate it. And again, I remind everyone, Easter deadline is today. Submit your abstracts and let us know if you submitted the abstract. We'll be gathering a team of 15 for Ukrainian delegation to Stockholm for Easter Congress. And we are looking forward to the next lecture in the month. So thank you, everyone. And thank you, Catherine, again.
Thank you again for the invitation to speak today.
Thank you. It was great. Bye-bye.
Bye.